Hi guys, I want to talk about Kubernetes, AWS, load balancers, and Terraform, and no Helm. Actually, I'm going to talk a lot of bad things about Helm. But first, very important, every time I say Terraform, you have to hear OpenTofu. I am looking forward to use it. I haven't had the opportunity, but I see that's the future. But that's just my opinion. Yep. Anyway, who am I? I am somebody who has to do a large talk in a very small amount of time, which means I'm somebody who talks fast. That's all you need to know. Yep. I work for Modus Create, a remote first developing company. They have offices in Romania, in the US, in Costa Rica. They pay us to go to conferences. And if I refer people, I get 4 digits as a bonus. So we have 40 open positions. You guys can do that as well. But, security, very important. I like security. What I'm going to say over here, don't do exactly like this at home, but for time's sake, I'll be quick. So let's talk about Helm and Terraform, or OpenTofu. First, Kubernetes. We all know Kubernetes, everybody talks about it, but one thing cool about Kubernetes is that they say it's cloud agnostic. Is that true? Of course not. But think about it. If Kubernetes is on AWS, you can quickly do it on Azure, you can quickly do it on GCP, you can quickly do it on bare metal, which pretty much means it's employer and employee agnostic. You can easily switch jobs to a different company with Kubernetes, instead of being in vendor lock-in or ECS, for example. But for a company, it's also good that people can hire people who know Kubernetes. It's a standard. A bad standard, for sure, but it's a standard which is better than no standard, right? Let me put my first deployment. Yes, that's a very simple deployment YAML. You can see that I have the deployment name 1, 2, 3, 4 times. Okay, the 4th one is optional, but the 3 of them, it is what it is. And if I write this 18-line file and I type, I call my kubectl K because, yeah. If I type kubectl apply f deployment YAML, I get this fancy message. And then what? Then we get this, Kubernetes dashboard. Oh, I wrote part of it, by the way. Anyway, you can see my deployment. You can see the replica sets. You can see the pods. The pod is there. It's running on a node, and it's worked. Simple, magical, one file, worked. That's good. But Helm, the elephant in the room. Helm is the same as that YAML, except to have 20 other files there just as boilerplate. Yes? But wait a moment, there must be a reason for that. Yes, there is. And for you to install that, the command is fantastic. Helm upgrade -n my first namespace --install sample /sample _ helm. And that's how you get it. Completely intuitive, very easy to memorize. You can even say that to your kids at night before they sleep, of course. What is cool about Helm? Kubectl is simple, but Helm has the very confusing templating language that is even worse than Jinja. Yes, but it remembers, because it has state, what it created, which is extremely good when it works, which is a very hard restriction here, yes? And it allows you to have variables separated of your Helm charts, which means you can have the same Helm chart and usually use with dev, stage, and prod. Sounds very good on paper. Limitations. Helm only talks Kubernetes. You want to get some resources from AWS, GCP? Forget it, not going to happen. What else? You have all these YAMLs. Yes, you push the YAMLs. You can see what is rendered, all the templates, but you cannot see the diff, what it's doing. You just have to believe that the Helm chart is going to do what you expect, and you can just compose Helm charts. Then for you to read a huge Helm chart, it's a pain, it's not practical, and for you to doing upgrades, you never know exactly what it's doing. It's for the brave. And horror story, once we decided the namespace itself wouldn't be created by Helm chart, so I innocently deleted the Helm chart, the namespace from the Helm chart. And then I tested in dev. Dev worked because there were a lot of things in dev. Staging, I didn't test with somebody else. That was a problem. And then we applied the Helm chart in production. It just did all the fancy changes, but deleted the namespace. Do you guys know what happens whenever you delete the namespace? It cascades deletes everything else. Yes? Somehow, I still happen to maintain my job after that. Yes? But that is the last time I decided to use Helm. Oh, actually, if somebody else writes the Helm, I don't care. But it's a waste of time. So my time is precious. Other people's time, I respect if they do them, but never again. Terraform. Terraform is just like Helm, except it works. Except that it has a real templating language that it's Turing complete, just like Helm, but it does much more. And it doesn't talk only to Kubernetes. It talks to AWS, to GCP, to Okta, to ServiceNow, and whatever else you can think of, which is great. And for you to use Terraform to manipulate Kubernetes is extremely easy. Take a look. On my left, or on your left, we have the Helm, the Kubernetes YAML. No, sorry, there we have the Kubernetes YAML, and over here, we have the Terraform one. Come on, it's one-to-one. I have no clue how many of you have seen this. Is the font size large enough? The cool thing of doing presentation on a phone is that I can zoom. Ooh. So, doesn't that sound like a YAML with brackets? Yes. So, the only difference is over here, on line 2, API version app/v1, that actually gets into Kubernetes deployment underscore v1. Yes. So, that is the only difference. Everything else is one-to-one, and one-to-one it is. So converting that is so simple that there is a tool for that. But we'll talk about that later. But now, why we should use Terraform instead of Helm? Over here in my deployment, let's say that I want to add an environmental variable, right? So usually what we do is, on line 28, I would just add an environmental variable. And if you're doing the Kubernetes, the Terraform syntax, it's like this. env, brackets, name, sample env name, sample env value. Yep. Nothing special, I just added 3 lines, and that you got from the diff that you can see over there in the top, right? Good. So what happens if I do Terraform apply? Simple. It says, hey, for your deployment, I am doing a change over there. That's why we have the tilde in yellow, and specifically, I am just adding this environmental variable. Do you know what else I'm doing? Nothing else. So you know what's going on. And then, so this part over here, I just had to scroll down. And then it's even saying for you, I am actually adding 0 resources, modifying 1, and destroying 0 resources. So you know exactly what you want. And if you're lazy and you just want to see the bottom part, you have that as well. I recommend you seeing both, but you have 2 ways of saving you from getting fired. Yes, highly recommend. And then just type yes, and you get exactly the same results. But now you know what is going on. Yes, so Terraform, as I said, it talks to your cloud provider, DNS, Jenkins, Active Directory, Kong, ServiceNow, Okta, whatever else is there, and if it's not there, whatever else you write. We had a fun talk on how to write Terraform plugins yesterday. Yep, I wrote one as well. It's made things easier. You done with the picture? Can I continue? Okay. Part 2. Okay. Do you have questions on this topic? Because part 2 is a different presentation. Please, louder. His question is, have I deployed custom resources with Terraform? Yes, I have. How do you do that? You can create custom resources with the Terraform provider. Yes. And then you just put them and they are there. The catch is you got to have 2 separate Terraforms. One that deploys the custom resource, and then a second one that, oh, there's light here, forget it. And then the second one that applies it. Because whenever Terraform does the plan, it expects the custom resource to exist. It's going to have to be a 2-step operation. They must happen in tandem, but it's completely possible, and I still recommend using Terraform for that as well. Okay? Further questions? Please.
Just wait for the microphone.
Or she says, and I can just repeat.
How do you lay out your Git directories? The way we do it is we have overlays for dev and then QA, and so we minimize the amount of work a single developer has to change, right? How do you do this in Terraform?
Okay, her question is, how do I overlay my Git directory about that? The easy answer is, we fight a lot about it. Yes, we didn't have an agreement. My personal opinion might not be the best, but hopefully not the worst. Symbolic links. There are other solutions about using TerraGrunt. I actually interviewed for TerraGrunt, and I asked them, why should I use TerraGrunt instead of symbolic links? And the developers of TerraGrunt answered, and I quote, there are multiple solutions for this problem. That being said, Open Tofu 1.9, that should be released this year still, is going to support for Kubernetes providers. And with that, it might be even easier to do the symbolic link things. Some of my colleagues hate me and the symbolic links. You have to choose who's going to be your friends. Yes? Okay, now I must continue. We can talk about that afterwards. Who here uses AWS with Kubernetes? Okay, enough people. Good, good, good. If you guys use AWS with Kubernetes, who uses Nginx as ingress? Okay, I forgot who does. Okay, yeah, whoever doesn't use Nginx as ingress, what do you use? Fabric. Okay, what else? SDU. Okay, good. Okay, but mostly I got 8 people or 6 at least using the ALB provider, the Nginx. Yeah, but we are in AWS, we are on a VPC, we don't have public IP addresses. Yes, we do have the public IPs that are double net, but the clusters come and go, it's a mess. So if you are in AWS and you use Nginx, you must have an ALB in the front. Good. So let's count. Browser talks to the ALB. That's one TCP hop. ALB talks to Nginx. Why? On the node port. Just because that's the way to get into the cluster. Second hop. Nginx says, woohoo, I'm getting this traffic and I am forwarding by the host name to the service. Third hop, right? Then what is the Kubernetes service? Wait a minute. Fancy name. Oh, I'm in the front. That's the. What is the Kubernetes service? Fancy name for an internal load balancer. So yay, load balancer, router in the middle, and then and only then we get to the pods. So we have 4 hops for this. You want to say something, please? Oh, he just made it worse. So 8 hops according to his math, right? Yeah, don't do that. Or suffer, I don't know. What I suggest? Okay, I'm going to define a load balancer with an image that makes, I had an image here. Yes, let's define a AWS load balancer. We have on the outside the load balancer itself. And then we have the listener rule, which just binds to a port, let's say 80 and 443. That's what normal people do. 80, you just have one rule. The rule is get out of here and go to 443, right? Hope you guys do that as well. And then on 443, we just have a listener rule says this domain goes to this target group, that domain goes to the other target group, right? Target groups can point to IP addresses, EC2 instances, Lambda functions, and other load balancers, NLB, for a very specific case. Today, target groups are going to be defined as a set of IP addresses. Nothing more, nothing less, right? Whenever you use the AWS ALB controller, what it does is, let's go back over here. What it does is, it spawns the ALB for you. That's a mess. It takes forever. Forever is 5 minutes, but I'm impatient. Yes. And then it crashes. And sometimes, not always, but whenever it does, what happens is that you have a dangling load balancer, right? And unless you have Amazon stocks, you don't like dangling load balancers hanging around. Yeah, it's expensive. And yeah, I don't like that. And also I have a personal problem with Kubernetes is, as somebody said in another talk and has been quoted twice, you have your 200 microservices with another 177 pods to control it and so on. And then each of the providers in Kubernetes send the logs in their own log. If you have other teams and they do something dumb and start polluting the logs, your errors are going to be in the middle of so many other errors, and you spend more time finding your errors than actually reading the problem. The less Terraform, the better, right? What is my proposal? Simple. The less Kubernetes, the better. Here, load balancer, we spawn with Terraform. Listener rule, Terraform. The listener itself, Terraform. The rule that writes HTTP to HTTPS, Terraform. And then we go and just get target group. We make it empty with Terraform. Then we use the AWS ALB controller to do one job and one job only. To get the IP address of the pods and add and remove to the target group as they come and go. That is done via a hook. It's no busy waiting. I don't like pooling. Yes. And which means that new pod is spawned, new IP is added. Pod dies, IP is removed. How does it look like? This. Hey, let's count hops. 1, 2, done. So suddenly you have way less stuff to break, way less stuff to stop working and to cause us trouble and give us headaches. Yes, the Kubernetes service is there, yes, because the controller reads from the service to see what it's going to put over there. But the traffic is just these 2 arrows, right? So now it looks like if it were EC2 instances, load balancer, pods, and no craziness in the middle. You wanted to say something? No? Does anybody want to say something? Oh, you're just scratching your nose. Okay, let's continue. How do you do that? It's a pain. You have to write a boring Terraform module, has to talk to AWS, has to talk to Kubernetes. There's many ways it can get wrong, but I'm your friend, which means, oh, does it work, first of all? Yes, it does. So here's the same target group, and then you can see that over here we have the IP addresses, right? It's exactly the IP address of the pods. And yeah, if you kill it, it disappears. If you put it there, show up. If I believed in live presentations, I would do it live. No way. Yes? So since I'm a nice guy, I wrote a module that does that for you, and it's on GitHub, right? So the module is there. You just have to put annotations, because I use Kubernetes annotation as tags. Deployment name, namespace, service selector. That's a part of the YAML. Well, we can talk about that. Yeah, but it's just a string, and it's usually the deployment name unless you think differently. Container listener port, name of the load balancer, name of the host name, and Route 53 zone ID. So it spawns the DNS for you as well. So it gets rid of external DNS as well. So another layer of problems that is just gone. Yep. Done? Okay. Good. How did I get there? Here. It's github/my name/presentations. The PowerPoint is there as well. Ooh, I did it on time. Questions? Please.
One thing I would like to point out, I think it's absolutely amazing having ALB directly pointing to the port using the, I think what they call it,
Target groups.
but container native VPC.
Yes, the VPC CNI. It comes by default with AWS EKS.
But there's actually a caveat with this implementation when it comes to the application side, considering when the port is terminated, perhaps due to a rolling deploy, the kubelet will be sending a termination signal to the port directly. Then if it's a web service, conventionally, the port will be terminated immediately. But on the ALB side, it's not necessarily aware of the termination, so you're likely to get some file 3 gateway error.
There is a German word for that. It's doch. It means no. It is the following. Whenever my module sets up creates a target group,
Yeah.
it says that, I forgot the term, but whenever you kill a pod, how long do you wait before you really kill it? And I'm evil. I set to 0. Pod gets killed, pod gets removed from the target group. There is no waiting for it to perish. I forgot the name of it, but
It is an issue for us.
set to 0. It works.
Okay, what we end up with is we delay the termination of the pod upon pod receiving termination signal, we sleep for 30 seconds just to make sure the pod itself is deregistered from the target group.
But that's application specific. So
Yeah, it's fair.
so your application is weird and creepy because I use it and we've been using that for 5 years in 2 different companies, and great.
Okay, yeah, perhaps on your side you have some sort of on files 3 on, you have a retry logic on the ALB side, perhaps, but
It's a standard AWS ALB that it just says if the pod dies, remove it from the ALB and stop sending traffic to it. It's that simple.
fascinating.
And then you don't have 503 because that connection is going to die. If you have a long connection and the pod dies, that's going to stop working. But it must be that way, right? But new connections, since the thing got removed, are going to go somewhere else.
Yeah, my point is that if it's set to 0, which is something I haven't tried out, maybe
That's it. Just set it to 0. Remove it, removed. Done. If it's not there, it doesn't receive traffic. It doesn't receive traffic, you don't get a 503.
Yeah, well, it was a raising condition for us, but I can only speak for myself. It might be applicable, but I'll pass the mic to someone else.
I think you want the microphone? No? Does anybody have further questions? Back there. Oh, that's going to be complicated. Or if you yell, I can repeat the question. Okay. Was it too fast? Did the presentation make sense?
Running really fast.
Yeah, I'm going back to what you talked earlier about Helm versus Terraform here.
Sure.
What is really the point of abstracting away from the pure manifests with things like Helm and Terraform?
Very good question. So I need to set up a DNS, right? I need to get secrets. It's not about using Terraform for Kubernetes. It's using Terraform to set my DNS, to get my Docker image, to get credentials from AWS Secrets or Vault or whatever you're fancy, to creating a ServiceNow shenanigans, to setting a GitHub action and to put in Terraform. So the way we do stuff in our company is the developer says, I need this. I said, good. I need an application. www.something.com. We spawn everything with Terraform, and then we set up the whole infrastructure with Kubernetes, and we have a Hello World container. And then whenever the developer is going to do their first deployment, all they do is they replace, the deployment only does is it replaces the Hello World container with whatever they developed. This way, we know we're working before, and if it doesn't work afterwards, we know who to point fingers. Did I answer your question?
Yeah, so essentially, if you only utilize resources within the Kubernetes cluster, then you don't
that's
see...
different.
Yeah, then that's different. Then just use plain manifest in your
yes,
opinion.
Yes. And yeah, maybe you're going to have your config maps or secret on a separate folder with symbolic links because of the environments. But yeah, we manipulate multiple stuff, and Kubernetes is just one of the things.
Check.
Yeah.